yes.
Yes, previously I was giving an introduction regarding CDC. There we have learned what is a CDC and what are the issues we are getting in a CDC and what is metastability. And to avoid metastability, what we are going to do, we are going to use synchronizers. And in that, I have explained you one example, that is two flop synchronizer. I have explained and I have stopped that. So now I have told you that we have a many number of synchronizers. So few of the synchronizers I am going to list out. Let two flop synchronizers we have, mux synchronizers we have, pulse synchronizers we have, as well as the handshake mechanism synchronizers we have. In the last class, I have told you regarding the two flop synchronizers, and there they have a many of are having a doubt that how can we say that for two clock pulses only we'll be getting output, or at one clock pulse we'll be getting an output without metastability. Here we will be taking, or we will be considering the output for every three pulses of a clock cycle. That means for every three pulses of a clock cycle, it should get stable. Then we'll check if the output was correct. So I hope you have understood the two flop synchronizer in the last class. So now I'm going for the mux synchronizer. See, explaining in a detailed of mux synchronizer better, rather than that I'll be giving you a overview, so that it becomes very easy for you to understand. See, if I explain through the diagram, if the input goes here, again it gets samplized here, again we'll be getting an output here. Instead of that, I'll be just explaining the overview, a brief overview, so that it becomes easy for you. See, mux synchronizer, it always works on an enable signal. Mux synchronizer, it works on an enable signal. So either the enable may be a 0 or the enable may be a 1. That means it may be a low or it may be a high. So whenever the mux synchronizer, whenever there is an input, and whenever the mux synchronizer enable is a high, that is it's a 1, the output doesn't change. It remains as the same what we are giving as the input. But when we come for the enable signal, it is low, that is to the 0. The output changes. Why it changes? Because the output of the destination flop in the last flop you can see in the diagram, that output is again, it is connected to the input of the mask. So in that cases, the output 0 is, whenever the output is 0, it gets changed. How it is synchronized? First, we are sending an input, and that passes through a flop, and from flop again it goes to the flip-flop synchronizer. It samples there, and here with the help of an enable signal, we'll be receiving a synchronized output. How we can be detected? With the help of an enable signal, like enable 1 and enable 0. If with the enable is 1, the output doesn't change. If the enable is 0, the output changes. Why the output changes? Because the output of a destination flop is connected to the input of a mux. There, in that case, the output changes and we get a synchronized output. This is about a mux synchronizer. Next, coming for the pulse synchronizer. What is the main motto, or what is the main theme of a pulse synchronizer? Generating a pulse. See, the main motto or the main theme of a pulse synchronizer is generating a pulse from one domain to the another domain. That means generating a sample pulse in a destination site is known as a pulse synchronizer. That means generating a pulse from one clock domain to the another clock domain is a pulse synchronizer. So how this pulse synchronizer works, let me explain. See, first we will be giving a pulse as an input. What will be giving? We will be giving a pulse as an input. So whenever this pulse is transferred and this pulse is converted into a level signal. What this pulse synchronizer do first? It will convert pulse signal into a level signal, and that level signal is passed to a synchronizer. Flip-flop two flip-flop synchronizer. What does pulse to level signal? This level signal is passed through the flip-flop synchronizer, and there the level signal gets sampled and we have to receive an output. So what I told in output, which should be a pulse. What I told, the output we should have a pulse. So what here? Here we have used one edge detector circuit in the output destination side. There the level again it is converted into the pulse and we will receive a sampled pulse in an output. So what is a pulse synchronizer? Pulse synchronizer is nothing but it is used for generating a pulse from one clock domain to the another clock domain, that is from source domain to the destination domain. First of all, here we are giving a input as a pulse and that is converted into a level signal, and again this level signal is transferred to a flip-flop, and a flip-flop in the sense we have transferred to a double flip-flop, two flip-flop synchronizer. There the level signal is sampled. There the level signal is sampled and again it passed through the output. Here we have to receive in the destination side pulse. So here in the destination side we have used a edge detector circuit. So with the help of the edge detector circuit, we will again this pulse is changed into the level signal. And again this level signal is changed into a pulse, and we at the destination side we will receive a sampled pulse. This is about a pulse synchronizer. Next, handshake synchronizer. So what is a handshake synchronizer? So here if we see, here, if you see, whenever the data is passed from the source side, it directly receives in the destination side. So, what this handshake mechanism or what this handshake synchronizer does is that first we will pass the data. What we will do first, we will pass the data. So, when we pass the data, automatically the data will receive at the destination side. What it happens automatically, it will receive to a destination side. So what this source side, what this flop will be waiting for, it will be waiting for a acknowledgement from the destination side. Acknowledgement in the sense, see the data is transferred from the source side, so the destination side is also the data received. So how this flop knows that whether the destination flop has received or not. So that's why it will raise a request to the destination flop that, see destination flop, have you received the data or not? So what this destination flop do? So destination flop sends an acknowledgement to the, again the destination flop sends a acknowledgement to the source side that yes, I have received a data. So what this the source flop thinks? Yeah, the destination flop received the data and hence the process continues and it sends the data in the form of packet. So here handshake synchronizer is very important. Once again, I'll be explaining you the input. Sorry, the first we will be sending an input to the source. So the source flop will send an input to the destination flop. But the source flop doesn't know whether if the destination flop have received an input or not. So what it will raise a request. The source flop side, it will raise a request to the destination flop side that, see destination, have you received a data or not? So the destination flop side one, it will send an acknowledgement to the source that I have received a data or I have received an input. So whenever this sends an acknowledgement to the input source, right? So the source flop will understand that yes, the destination flop has received the data and it will continue the process and it will send this data in the form of a packet. So these are the main synchronizers: two flop synchronizer, mux synchronizer, pulse synchronizer, and handshake synchronizer. So next, rules of CDC or goals of CDC. So what are the rules we are performing in the CDC or what are the goals we are going into the CDC? CDC setup analysis. So here we are having three rules. The first one is a CDC setup analysis. The second one is a CDC verify trust, and the third one is a CDC or RDC verification. So what are the three rules? The main. So whenever you attend for an interview, this is the main question. The first they'll be asking, what are the goals of CDC or what are the rules of a CDC? So what are those? CDC setup analysis, CDC verified trust, CDC or RDC verification. So in CDC setup analysis, what are the things will be going on? The tool will check for clocks, whether the all clocks are present or not, all the resets are present or not, all the file compiling issues are there or not, all these were checked under the CDC setup analysis. So what does the CDC setup analysis does? It checks for the, so always everything is run by the two. So when we check for the CDC setup analysis, what it does, it checks for the clock, it checks for the reset, it checks for the all the files, whether the all the files are library files present or not. It checks for the compiling issues. Next, second one is CDC verify step. In the second step, what the tool does? What the tool does? Tool will check whether the clock is defined or not. What the tool does? It will check in the second step. It will check whether the clock is defined or not, whether the reset is defined or not, whether all the constraints are present perfectly or not, whether it is in the same path or not. Everything was checked in the CDC verify struct. What the CDC verify struct does, the tool does, here it will check whether the clock is defined or not, whether the reset is defined or not, whether the constraints present or not, whether the group or path library was there or not. Everything checks under the CDC verification verify struct. And next third one is CDC or RDC verification. What the CDC RDC verification struct do? It checks for the convergence, divergence, and weak convergence properties. So the rules and goals of CDC are mainly three: CDC setup analysis, CDC verify struct, CDC RDC verification. So you may get a question in setup analysis, what all the tool do? What it does, it check for the clock, it check for the reset, it check for the file, compiling issues, everything. Next, CDC verification, verify struct. What it does in the second step, it check whether the clock is defined or not, reset is defined or not, whether the constraints are present or not, everything it checks in the second. And the third one is CDC or RDC verification. Here it checks for the convergence, reconvergence, and divergence. So this is also a very, very important topic, rules of CDC and goals of CDC. So, what are the real-time errors we can see in a CDC? So, let me explain you what all the real-time errors we can see in a CDC. So, after running all these, if anything issue or if any wrong, the tool throws some errors. So, what are those errors? Fatal errors, clock mismatch errors, reset mismatch errors, AC sync 0102, AC glitch 03, AC clock info. Sorry, it is a clock. Last one is a clock info 0505B. So, what are the fatal errors? What is meant by fatal errors? So, fatal errors are nothing but the tool. If you have any comma issues, if you have any syntax issues, if you have any margin issues, all these comes under a fatal error. So what all comes under a fatal error? So commas, margins, any syntax error, any small design issue, all will be coming under the fatal error. Next, clock mismatch. Clock mismatch error means the name of a clock may be mismatched. Sometimes edges may mismatch, faces may mismatch. There's and all due to error called clock mismatch error. And there what, so if we get a clock mismatch error, we have to understand that yeah, there is some in a some particular line there is a mismatch name of clock or face or edge. Reset mismatch error. So what is a reset? Here we will be having whether it is an asynchronous research, reset, synchronous assertion, or deassertion. If there is any problem regarding that assertion and deassertion, reset mismatch comes under. AC Sync 0102, metastability. If you have a metastability issue, in the starting class, I have explained you regarding a metastability. So, if you have any metastability issue, it will through an error called AC Sync 01 and 02. So, if you have any metastability issue, it will through a AC Sync 01 and 03. So, AC glitch. If you have any issue regarding a glitch, so whenever you use a combo logic or whenever you use any logic, we will be having a glitches. So if you have any glitch in between a design, if you have any glitch in between a project, so that will through a error AC glitch 3. So these are the errors which you can see in a real-time hands-on experience. So the tool doesn't say that, see, you are having a comma error, so go and check whether the comma. It gives that. So you are having some fatal error. So and so like you have a fatal error. So we have to understand it. So fatal error mean what? Margin, comma, comments, everything that everything comes under fatal error. So on particular line we have some fatal error. So you should go and delete it. Same clock mismatch error. So you have a clock mismatch error. So particular line you have a clock mismatch error. So you have to go through that. So like these the tools through errors based on that we have to rectify the errors and proceed for the design. Next MTBF. So MTBF comes under a metastability set. So yeah. So what is MTBF stand for? MTBF stands for mean time between failures. What is an MTBF stand for? Mean time between failures. Why we use this MTBF? So to measure an average time of an equipment or to measure an operating time of an equipment is a MTBF. See, MTBF is nothing but a life of an electronic gadget. So you have a laptop or you have a mobile phone, you have a semiconductor transit chip, you have a SD card, you have a pen drive, whatever it is. MTBF is calculated. That means for how many years or for how many hours it works. That means a good MTBF have a good lifetime of a device. That means more MTBF if you have that object or that equipment or that electronic gadget works more days. MTBF is nothing but it calculates the average time of an operating system, the average time of a particular gadget, that is known as an MTBF. You can ask the bad MTBF gives a less time of an operating system, but good MTBF gives a more or increased lifetime to a device. This is an MTBF. Next, see, this is about a CDC. So, what all the question when you go for an interview or when you face an interview, few questions will be coming further. In few questions will you get from the CDC. So, how the questions they may ask? What is meant by CDC? So, they may ask what is meant by CDC. From starting, if you have listened, you can answer. What is meant by CDC? CDC is nothing but transferring a data from one clock domain to the another clock domain is known as CDC. A simple relevant answer. Next, how does the metastability occur? See, here we are using a mainly metastability occurs based on asynchronous clock. So when the asynchronous clock is transferred from one domain to the another domain, they have a phase relationship. They have a different phase relationship. They have a different phase and there will be some timing violation. According to that, we will be having a metastability. So, what is a metastability? Metastability is nothing but it is an unpredictable condition where we cannot judge whether the data is to the either to zero, not to one. It will be in a between hanging either not to it doesn't go for the zero, it doesn't come for the one. It will be hanging in between. That is what is metastability. Explain two flop synchronizer. You can say that the two flop synchronizer is placed between a source and destination. So whenever the input sent from the source and that the output is given to the flip flop and we get an output with the two clock pulse delay, we will be checking the output stable for the three clock pulses. Like that you can say. What is a pulse synchronizer? You can say that the main motto of pulse synchronizer is to generate a pulse from a source to a destination, one domain to the another domain. First, we'll be sending a pulse. The pulse is converted to level. Again, the level is passed through synchronizer, and the level is converted to pulse with the help of a edge detector circuit. And finally, we receive a pulses with a synchronized, sampleized pulses. What is the handshake mechanism? Handshake mechanism is nothing but the source sends a input and it waits. The source sends an input and input the data and the data is received by the destination flop. The source sends a request to the destination flop that whether it has received or not. So the destination flop sends an acknowledgement to the source flop that I have received and hence the process continues. That is a handshake mechanism. What are the goals or rules of TDC? CDC setup analysis, CDC verify step, CDC or RDC verification. Next, what is an MTBF? You can expand that, and what is MTBF do? It calculates the average time of an equipment. What are the inputs of CDC? Main question. What are the inputs of CDC? Dot SDC file, dot library file, dot V file, dot path library file, all comes under inputs of CDC. Next, what are the outputs of CDC? We will be getting output as a dot report file. Those are the outputs of CDC. What are the errors you have seen in CDC? Fatal errors, clock mismatch errors, reset mismatch errors. You can write AC sync 0102, AC geek 03. All these comes under errors. So this is a complete overview topic of a CDC. So if anyone have a doubt, you can just ask.
Hello, ma'am. One question.
Yeah,
Hello.
yeah. One minute. Hello, 1 minute. 1 minute. Let me close this PC. 1 minute. The system got hung. Yes, you can.
Yeah. So the thing is like, what is the difference between two flop synchronizer versus pulse synchronizer versus the other handshake synchronizer?
Yes.
So
Yeah, yeah, yeah.
what is the
Here,
difference between
yeah, yeah, yeah.
any
In
advantage of one over the other?
yeah, yes, here the two for synchronizer we can use only a single bit data. When we go for a multi-bit data, there will be chances of losing a data. And here in the pulse synchronizer, we are sending a data in the form of pulses, so we can have a less chance of losing the data. So here handshake mechanism is the same. When we keep on going sending the data, so the destination flop also should have that much capacity or that much fast to receive a data continuously. So when we keep on sending, we don't know whether the data is received at the destination flop correctly or not. So when we keep on sending, first data will be received, last data will be there. We'll think that all the data, but it finally what happens? Some data will be missed. So in that cases, what the handshake mechanism do? It is using a request and acknowledgement process so that we can know whether the data is received. That the actual data without any losing we will be receiving. So this is the difference between two flop, pulse as well as handshake mechanism.
Ma'am, one more question, follow-up question. So in
Yes,
handshake clock synchronizer, right?
yes,
So every time we send every data, it has to be acknowledged, or like it's a group of data we need to
yeah.
acknowledge or
It is
something.
a yeah. The data is sent in the form of packet. So for each packet, it should acknowledge. The packet contains some amount of data, like in a group of
Okay.
packet in the sense a group of signals or group of data. So for every packet, it takes an acknowledgement.
Okay, for every packet, and whereas
Yes,
like for others like what I mean is pulse synchronizer, every data it will do the pulse and create the pulse and then again detect it, right? So
yes,
that's how it will be,
yes,
right?
yes, yes, yes,
Okay, okay, ma'am.
yes.
Thank you.
Okay.
And hello, sorry, one more. Hello,
Yes, sir.
hello.
Yes, tell me. Yes, tell me.
Yeah. So any disadvantage of this pulse synchronizer means what I mean to say, like, is there any measure through which we can say like this is the best or this is the worst
So,
CDC
yeah,
crossing domain?
see, we can't say that this is the worst, this is the best. So each and every synchronizer has its own functionality. See, here we can use in a two clock synchronizer. I told you we can use only a single bit. We can't use multi-bit. When we come for the
Okay.
pulse, we can use a multi-bit data. Here, if we that means the two clock has a functionality to simple or sample or synchronize for single bit. Here for pulse, it is having only it has that advantage of pulse. The handshake it is having only to say sample the packet. So that means for each and everything, it has a particular date, own particular what is it? It has its own technique. That's it. So this is the best. This is the worst we can't say. But all these three nowadays we are using a asynchronous FIFO because in all these three we can't store a data. But when we come for an asynchronous FIFO, we'll be using a dual port memory. So there we can store a data. So that's why instead of all these three, we are using asynchronous FIFO. I didn't explain you here regarding asynchronous FIFO synchronizer because when I get for the FIFO topic, there I will be there. So that's why I didn't explain you FIFO synchronizer.
Okay.
Got it?
So basically, right now in industry, we are not using anywhere CDC kind of thing.
No. CDC we are using basically CDC link synthesis is very important to check for each and every design. So if you doesn't do CDC, how can you say that the clocks are correct or the clocks are in a correct manner? Every design and every function it works on completely clocks, resets and all, right? So without
Yes,
doing
yes.
CDC, how you go for the next step? Got it?
Got it.
But using techniques were different. That's it.
Okay.
Yeah.
Okay, ma'am. Thank you.
Yes. Yes. Anyone? Yes. This is this is about a CDC. So what all I have given you in a point of interview point. I have given in the point of interview. That means an interviewer how they make questions, how you have to answer. So that means overview topics I have given you. To the depth, if you keep on going, we can just get a knowledge, but we can't answer to the interview. So the interviewer may ask what is the meta stability. So you can just say the like meta stability is that dot and all. We can explain such a long process, but the interviewer doesn't have a patience to listen such a complete process. So to say in a simple shortcut way, a simple line I have explained you. So you can just clarify, you can just go through the PPT, I'll share you. If you have any doubts, you can just ping me at any time. You have a WhatsApp number in our group, and you can just see in that and you can ping me so that I'll explain you whatever the doubt you have. This is up to the CDC. If you have any doubts, you can just contact to my number. Is it clear for everyone? Yes. I'm leaving the class. Thank you and having a patience, valuable with having your time and listening. Thank you.
Yeah. Thank you so much, Roshan. Thank you so much. Thank you.
Yes, yes.